This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Developers, got some extra time on your hands? Use it to learn a new database. InterSystems Iris allows you to choose your language, tools, and environment, so you can collaborate, build faster, and deploy more efficiently. Now's your chance to try out InterSystems Iris, the fastest way to build applications. Ready, set, code. Visit intersystems.com/tryiris to learn more.
Welcome to Software Engineering Radio. I'm your host, Gavin Henry, and today my guest is Tim Sneath. Tim Sneath leads product management for Flutter and Dart, working from Google's office in Seattle. He joined Google in 2017 after 17 years leading client platform and developer teams at Microsoft. In his spare time, he tinkers with various retro computing projects, battles with the New York Times crossword, and attempts to persuade his mother that customers aren't out to get her. Tim, welcome to the Software Engineering Radio. Is there anything in your bio that I missed that you'd like to add?
No, I think you you hit a lot of interesting things there. Yeah, I've been playing with computers since I was a little boy, a wee boy. I grew up in England, and my very first computer was a ZX81, and it's funny because I still have that computer literally in my drawer, and every now and again I get it out and just marvel at how computing has changed so much over the last years. We've been living through an incredible time of revolution that I think in 100 years' time people will look back and marvel at. So retro computing's been my thing for a little while.
And retro doesn't really take that long to become retro nowadays, does it?
That's very true. Although it seems like there's a growing lifespan for computers with the decline of Moore's law and with the way that various different efficiencies are shifting in terms of what performance looks like. It does seem that people have computers that are 7 years old, and that wasn't the case at any other point in my life. It's interesting to see how things are shifting and probably will continue to shift.
So during the show, we will mainly be talking about the architecture of Flutter. However, I'd like to start with an overview of cross-platform development, Flutter's history, and the Dart programming language. So Tim, what is cross-platform development?
Well, that's a very broad space, of course, because people have been building software that runs across multiple platforms for almost as long as software's been around, right? I mean, Unix was a cross-platform, or was written to run on different computing architectures and hardware. So in the broad scheme of things, all we're talking about here is writing software that isn't tied to a single operating system or device. As we think about Flutter, though, and we think about mobile technologies and cross-platform in this specific domain, really what it means is that when you're building UI, when you're building user experiences, being able to take those experiences to different kinds of device and platform. And for us in Flutter, that means building apps that run on iOS and Android on mobile devices, building apps for desktop, that's obviously Windows, Mac OS, Linux, and building apps that also support the web, and being able to do all of those things from a single code base, being able to do them all from one set of code, which in the case of Flutter is people write their code in Dart, and that targets all of those different devices.
Do you think we should maybe tighten up the phrase or term cross-platform development for cross-user interface platform development in this?
Yeah, I don't hugely like cross-platform as a term because it implies, or historically has implied, some kind of lowest common denominator, or an experience that is limited. We sometimes describe it from our side as multi-platform, because that sort of implies, a slightly different range of optimizations. And that's but every word is overloaded in the computing industry, I guess.
It does actually make more sense to say multi-platform. Is it multi-platform development?
Yeah, multi-platform, multi-device. To an extent, we go with the lingo, the nomenclature that exists out there, and everything is built on something else, right? So I think of Flutter as cross-platform development without compromise.
That's a much better definition. Okay, so if we sort of take the various components that we've mentioned there, Windows, Linux, Mac, web, and sort of bring it back to just mobile for a few questions and minutes. So there's been quite a few different, I don't like using the word attempts, but quite a few different frameworks over the past sort of 10 years or so, targeting mobile. So you can have one code base and it spits out a version for iOS, Android, Windows. Why do you think there's been so many attempts? And which brings me on to, where did Flutter come from, and Dart as well?
Yeah. Well, I think it's an immensely attractive proposition to be able to build an application that can get to all of your customers at once. Is like one of those holy grails for developers through the years. You're a startup, right? And you're trying to prove that your great idea is viable. It's critical that you're not artificially limiting your access to customers to just those that are running a particular operating system or have a particular brand of phone. Or you're an enterprise and you're trying to get your customer experience out to every customer at the same time with a consistency of experience and quality. Again, it's a very unusual environment that I can't think of in almost any other scenario that you'd say to somebody, hey, we're going to build 3 separate parallel payroll systems, for example, that are all going to be developed, have the same features and run in parallel with one another. So, UI is one of those areas where we want people to be able to have that same consistent experience, at least in terms of, releases and time to market and quality, without the sacrifices that sometimes come from that kind of experience. And that's really the value proposition, to use business language for Flutter, to give you that ability to get high quality, high end experience to all of your platforms simultaneously. A little bit about where Flutter came from, and Dart, which is the language that you build Flutter applications with. They both stem from the web, actually. There were 2 separate parallel teams working on different problems associated with web performance. If you go back 5-6 years ago, both the Flutter team and the Dart team were exploring, how can we build a better web? How can we create a better software delivery environment? And for the Dart team, that came from explorations around JavaScript and virtual machine technology. For the Flutter team, that came from explorations around UI presentation models and some of the limitations of, at the time, HTML and CSS as they then were. And some of those experiments were focused on exploring what would happen if we deliberately broke backward compatibility. If we said backward compatibility wasn't a goal for the web, what could that provoke in terms of disruptive insights to how the web is created? And not with necessarily a goal to break the web, but more to understand where the limitations and barriers are in the web as we currently have it. And that led to a whole bunch of different insights, from which came both Flutter and Dart as a UI framework and a programming language, and also improved the web itself, generated insights that create a better web platform for all of us to build on. And that is, of course, the web that we have today with a high quality, pervasive experience. So that's a little bit about the story of Flutter and Dart to date.
And where did the name Flutter and Dart come from? Who has that?
Oh, that's a good question. Where did they come from? I think Flutter came from, in part, a company that we'd bought. It's very hard to come up with brand names and trademarks that don't already exist, and so Flutter. I think we had a if you like a name on the shelf that we had already been through, some of our trademarking and domain name purchasing, and so that's where Flutter came from. I actually don't know where Dart came from as a name. It had an earlier name of Dash, and then it became Dart. And it's a great question. I don't know the genesis of that piece. It predates me on the Dart team.
I'll Google it after this, and I'm sure
Okay.
I'll get a link for the show notes. Yeah, so that was a really interesting comment you made about forgetting, see if I've got this right, forgetting the web as a sort of primary platform and imagining it wasn't there and seeing what you could do. Because I understood that when you write the single code base in Dart and Flutter, that the web output, as it were, of that code when you build it was quite a recent add-on and only in the beta versions. But the way you described it there, it was one of the first goals, or have I misunderstood?
Yeah, it's really funny. We've kind of come full circle, right? Because we started with this sort of presumption, at least as a presumption for the project, that breaking compatibility with the web was the only way to deliver the beautiful, high quality experiences that we wanted to be able to bring to different platforms. But then as we got closer and further into the process, the web itself has continued to evolve. And so now we've kind of come back full circle and looking at how do we bring Flutter back to the web? How do we take the UI that you create with Flutter and translate it back to run on the web platform? And of course, the web has progressed significantly over this period of time. We've made a lot of progress in how the web has evolved, and the web has improved in its own access to the underlying operating system. The web continues to improve in terms of performance, and so we're seeing that that's starting to also have its impact in terms of how Flutter is able to target that. And so, as you say, we have started with Flutter on mobile. We added early support for desktop and web over the last year in a preview mode, and we're starting to find that some of the improvements on the web are enabling us to build surprisingly high quality experiences, and that's using things like WASM, which is that sort of binary compilation for the web.
Yeah, that's WebAssembly, isn't it?
Yeah, the WebAssembly experience. And then CanvasKit is a port of Skia, the 2D graphics engine, to WASM. And that lets us get that full kind of OpenGL-like sort of experience for the web without sacrificing the performance that inevitably comes from all the other layers of things like the DOM and having to go through the traditional document-orientated model of the web.
Yeah, I was going to touch on Skia later on in the show because that's what the rendering part of Flutter is, if I got that right.
Right. If you drill down through the layers of Flutter, what Flutter is essentially is a UI framework that sits on top of a graphics engine, and Skia is the graphics engine. And that in turn is what writes the GPU instructions to actually physically render content.
That ties us back actually to a show we did. I haven't got a note of the number, but it's the one about writing software with Yuval Lowy, because he speaks about architecting your software, so all the different bits are components, and that's what you basically did with Flutter. Is rather than have a primary target, you just made that a possibility. The web's a possibility. The desktop's a possibility.
Right. Yeah, the shift is like historically, when you start a new software project, your very first question historically would be, well, what am I building, right? Am I building a web app or an iOS app or a Windows app? And we want to literally turn that question on its head. We want you to start with the question of, what do I want to build? What is my grand idea? What is the design that I want to create? And make that question about, and what platform does it run on? We want to make that literally almost the last question you ask in the packaging phase of your software development project. And that's a huge kind of paradigm shift, right? It's a very significant disruptive idea, but with tremendous potential for shifting how apps are built.
Yeah, because normally it's, or right, if I'm building a mobile app, I need to do it that way. If I'm doing a web app, I do it that way. And it's completely not the right question to ask. Like you mentioned earlier, it's what's the business need or the consumer need here, and the rest is a bolt on.
Right.
I just wanted to reinforce the comment you made about creating the code base and then it works on the web. So I've been doing some Flutter apps, just to get ready for all this, and did one and then ran it so it spat out a version for Google Chrome. And it just worked immediately. And I was like, oh my God, this is amazing, And I think when someone just picks up Flutter and runs the demos and reads the high qualityness of the documentation, I think that penny just drops and opens a whole. I'm totally biased because I love it, but that's the benefit of being a host. You get to pick the topics you want to talk about. So I think we'd almost finished the introduction section. We've got a few more minutes just to get a couple of questions in before we start to roll up our sleeves and get into the architecture. So could you give me a couple of minutes on if Dart was created at the same time as Flutter, or they were just parallel projects and you tried a few other things? What would you say Dart is similar to, and why was it chosen?
Yeah, Dart's a very interesting language for a couple of reasons. It was very much a parallel project to Flutter. They didn't start at the same time. In fact, the very, very earliest prototypes of Flutter used JavaScript as the programming language behind it. And Dart was really very much a distinct project going on in a very different part of Google. It was developed in Denmark by a team in Aarhus in Denmark. And the uniqueness of...
And was that part of Google then? Or
Yes, yeah, just a different physical location way outside of the Mountain View campus, as it were. The things that are unique about Dart are really architectural and relate to its technical envelope. Typically, languages focus on picking a particular niche. Every language has its technical envelope, the space with which it's perfectly suited. Go, for example, has been very much driven by the needs of server development. JavaScript, of course, driven by the web. Java originally, built around this JVM, this Java virtual machine that has proven to be tremendously valuable over the years. But they all impose their own restrictions, constrictions, specialties. And for Darts, the things that are pretty unique about the Dart technical envelope relate to two things that I consider some of the secret sauce of Flutter. Firstly, Dart is designed not around a single target compilation environment. So Dart supports both production JavaScript transpilation and compilation to native machine code, whether that's ARM or Intel x64. So that ability to target all of those different platforms gives Dart a great deal of versatility. And then the second aspect of Dart is that it's both designed around a high quality development experience and a high quality runtime production experience. So we have these two different compilers or two compiler modes for Dart. During development time, we ship a small VM to the development target. And that supports features like stateful hot reload in Flutter, which means I can make changes to my Flutter code and I can just patch the running code with the Delta, and the VM's able to just accept the patch and continue running the code in real time. And there are other languages that do that, right? JavaScript allows you to iterate and make changes in real time. But what it doesn't have is that production compilation mode. JavaScript is very much designed around the JIT compiler that is there and is present interpreting your code. And so that's sort of one of the unique sort of strengths of Dart as a language. It has this matrix of both web and native compilation and developer and runtime execution. And it's that 2x2, if you like, of those two different things that gives Dart an envelope that is really quite unique compared to other languages. I can't honestly think of another language that offers production quality support for all of those areas. There are languages, that support experimental modes. There, for example, I think C# has an experimental transpiler to JavaScript, but there are very few that have that production tested quality for both of those two things. And the fact that Dart itself is used by Google's ad framework, for example, our ad team uses Dart for processing, for the work to enable advertisers to bring ads to different devices. That means that we've already demonstrated millions of lines of production quality code transpiled to the web. Similarly, we have, of course, now hundreds of thousands of Flutter apps that are compiled to native machine code. So again, that's kind of the uniqueness of Dart as a language and its opportunity.
And the ad portion of Google is not a trivial portion, so that kind of highlights the quality of the chosen language.
For sure.
Do you have any comments on the long-term goals or plans for Flutter at Google, or is that just not something?
Yeah, I mean, one of the kind of core principles of Google, one of those classic statements is, if we focus on the user, then the rest follows, and that's very much been our organizing or sort of cultural principle for Flutter. We want to build software that people love and use, and develop its roadmap and direction based off how people are actually using it. So we continue to invest in this broadening out across different devices. We're seeing a lot of excitement about Flutter on desktop, for example. Lots of cool samples I'm seeing and prototypes that people are starting to build there. The web, similarly. So we develop in the open, of course. We have an open issue log. We look at the top issues. We look at real customers and how they're using Flutter and Dart and evolve based off that. So I think you can expect to see us continue to evolve the product based off those needs. Our immediate focus is, of course, to get the various different announcements we've made so far to stable quality, and those are desktop and web on the Flutter side, and sound null safety on the Dart side. And so those are the big immediate elements of our roadmap.
Yeah, because you mentioned, you announced Windows support 2 weeks ago, a week ago, in the latest version of stable.
The alpha for Windows support, yeah.
That's right. And null safety. Can you touch on that for a minute?
Yes, of course. Yeah, null safety is that again one of those kind of classic sort of language features that seems to offer tremendous promise of being able to control whether variables are nullable or not. And there are quite a few languages that offer support for non-nullability, being able to prevent or being able to express in the type that a variable it cannot contain a null value. And the goal here is primarily minimizing errors, right? That null reference exception that people will be familiar with in many languages has been the source of countless bugs over the years. I think it's been described as the $billion mistake in the past. There are good reasons for nullability, but being able to protect against that and guard against nulls appearing where you're not expecting them is clearly valuable. And again, one of the things that's rather intriguing about Dart's implementation is that it's not just expressed in the code, but it's a sound expression, meaning that the type is reified throughout the lifetime of the code. We're able to provably enforce non-nullability throughout the code. So as the flow of the programming logic goes, we can assert at the compiler level that there can not be a null field in this type. And many language implementations, particularly those that have retrofitted nullability or non-nullability, are not sound. They support it, but at runtime they still have null detection in there because for reasons like reflection or other language specification gaps. They're not able to prove and assert that there cannot be a null in a particular variable. And we're just getting this work mainstream. Just literally last night, as we record this, we have completed the work to bring null safety into the Flutter framework. And our very, very, very early experiments with simple examples are showing performance improvements of the 5 to 10% range, and the same for reducing size of the code, because we no longer need the instructions to guard code against nullability.
Oh, I look forward to having a play with that and possibly doing another show on Dart by itself. Okay, I better move us on. So we're going to sort of dig into the architecture of Flutter now, the guts of the show. We've covered Flutter's history, where its name came from, why Dart was chosen, how that developed, and I won't say cross-platform development, we'll say multi-platform development now. So I'd like to get down to the nitty-gritty of what makes Flutter tick. So what are the architectural layers of Flutter?
Well, I should preface this by saying I'm a product manager, not a software architect. So I kind of feel humbled by your some of the other guests you've had on the show that are certainly deeper than I am, or have
we're not getting too deep, don't worry.
But fundamentally at a high level, Flutter is built with what Ian Hickson, our technical lead, likes to describe as the mahogany staircase. And the principle here is that we've built it as a series of layers, and each step is self-standing in its own right. It's something that does not have privileged access to the layer below, and so every layer is theoretically optional and replaceable. So from the ground up, of course, every platform has its own core primitives, whether it's something like OpenGL or DirectX, or the layer that physically is responsible for the interaction with the underlying hardware. With Flutter, we have a layer which we call the embedder, and the embedder is responsible for setting up the application platform, interleaving the application with the underlying operating system, setting up threads, setting up the event loop, handling the creation of a render surface and passing that across to the higher level layers, handling things like passing mouse input and touch input, depending on what device, to the higher levels.
Just to ask a couple of questions about that level. So there's 3 layers in this, I would say, after some research, and the embedder is probably the biggest abstraction layer. So it allows you to work with all the different things that you're targeting. Is that?
Yeah, the embedder is platform specific. So we have one of those for every platform we target. On Windows, of course, that is written in C++. On iOS, it's written in Objective-C, and so inevitably that is the piece that is utterly specific from platform to platform.
And that's the bottom level of this framework.
Right. Yeah.
Okay.
Right now, there's no better time to learn a new database. With InterSystems Iris, you can build the applications you want however you want them. You can connect your systems, use any data model, and apply machine learning. So you can build data-intensive and mission-critical applications in no time. Level up your skills with InterSystems Iris, the fastest way to build applications. InterSystems Iris Data Platform. Ready, set, code. Visit intersystems.com/tryiris to learn more.
And is the embedder similar to, we'll speak about the elephant in the room, React Native. Is that similar to those types of frameworks where they have JavaScript that breaks into the bottom layer through channels or plugins, native plugins, as it were?
Yeah, I'm obviously no expert in React Native. My understanding of how they work is that they provide JavaScript as a language to target the underlying operating system.
which would be similar place in the stack to where Dart is, possibly.
Well, I imagine it's somewhat different because in React Native you create, for example, a button, but React Native doesn't provide that button. The JavaScript code is telling the operating system to present a button, but I have no real concept of
Okay.
how that happens.
It's probably a bad point to bring that in. I just wanted to highlight that the embedder is the bit that sort of platform specific, like you said.
Right,
Okay.
right.
Excellent. And the layer up from that.
Yeah, so the embedder is literally kind of like the bootstrapper, if you like, for the application. The actual rendering takes place using the Flutter engine, which is in the desktop and mobile versions is a C++ layer. You can see it if you go.
And that's the top layer, isn't it?
That's kind of like the middle layer, if you like, the engine. So if you go to GitHub, you can see there's actually a repo for the engine itself, and it's mostly C++ code. The engine is responsible for the actual physical kind of frame by frame composition for Flutter code. So it takes the whatever you write at the top level, which we'll talk about in a moment, and is responsible for compositing onto a physical surface. So it handles things like, it's time for a frame to be painted. I need to go and take the various different elements, the render elements, and physically composite them on the screen at the right resolution. I need to grab, for example, an asset, or I need to do the font layout and text layout and rendering. I need to be able to handle an event like a mouse or a touch event and detect which element that affects, so I can bubble it back up to the higher level. So that's the engine, and say that's the native code. That's C++ compiled code that is a core part of the Flutter engine. You as a Flutter developer never touch that, of course. It's the low level implementation that implements the work that you write.
So the developer works in the framework layer, which is the top.
Which is the third layer. That's right. So the framework is the Dart code that you can typically see if you're using an IDE like Android Studio or Visual Studio Code, and you click into something like a button or a material app or an animation widget. That code is written in Dart, and that's again compiled because the Dart code is compiled into the underlying machine code. And the framework is responsible for representing the engine to user code. And so that's that level that has the core, if you like, developer primitives like animation or gestures or the widget library. We often sort of say in Flutter everything's a widget, and so that's the building blocks of everything that you see in Flutter. And so you can see that code. It is responsible for the orchestration of high level widgets like a button into the lower level widgets that or elements that are responsible for rendering that, which of course includes maybe background rectangle and some text that it renders on top of that rectangle, and perhaps a shadow or something like that. And that's what the framework level provides in Flutter.
Okay, I'll just stick this all together so we don't get lost. So we've got Flutter, which is all of those three layers.
Mm-hmm.
Is that?
That's right.
And the three layers would be the top, which is the one that you work in day to day as a developer, which is the framework, which is pretty much Dart.
Entirely Dart, yes.
Yeah, Dart, all Dart, but it's confusingly called the framework when actually Flutter is the framework of everything.
Right.
So that's Dart, and that's where we would sort of live and breathe normally. Then the next layer down is the engine, which is written in C and C++.
Yeah.
And that's responsible for speaking down to the next level, which is the embedder, which is the platform-specific one. So that has Objective-C for iOS. Is it Java for Android or?
Yeah, a mixture of Java and C++ on Android. Yeah.
C++. And then Windows will be C#.
C++.
C++.
Yeah, C++. Yeah.
Same for Linux as well?
Yes. Yeah.
And those three layers make up the Flutter name, as it were. So in the Dart framework, we've spoken about widgets. As I understand a widget, it's a name and it has various parameters to that name, and it does something.
Mhm.
Is that how you would describe a widget?
Well, so a widget is really the unit of composition for
Okay.
Flutter. It's essentially the building block of a Flutter UI. So it's essentially a declarative component that everything in Flutter is built on. So again, if I think of like a typical the Hello World app, if you like, for Flutter, typically there's a material app, which is this if you like the host application widget. There's a scaffold which provides the kind of classic, like a title bar and maybe some toolbars at the bottom and the sort of the canvas.
And material, we're talking about the material user interface guideline that Google.
Right, the material design system, which is one of a couple of different ways you can build apps in Flutter. But again, it's the default, so I just picked that one up. So material app or scaffolds, that itself is a host for an app bar, which might appear at the top, the canvas itself of the main sort of body of the app, and maybe some buttons at the bottom. Every one of those things are widgets. But then if I take something like that tab bar at the bottom, right, that itself is probably a combination of 4 or 5 buttons that themselves are widgets, along with a parent container that is itself a widget. And then if I drill down into the button itself, the button is probably composed of itself multiple widgets, an icon and some supporting text and a background. So you get the idea here. Really, what we're building up is this sort of hierarchy of composition, and that's the kind of core organizing principle for everything you build in Flutter. When you create a widget, you're responsible for overriding the build function to return a new element tree. And so if I create my own custom widget, or I create something like, again, a material app, what I'm really doing is I'm representing the build method. And that method is called whenever there's a change in the state of the application to update the element tree that then Flutter itself is responsible for rendering.
Yeah, so if you imagine you've got let's take a mobile platform, an Android simulator, you're looking at the screen or you're looking at your phone. If you imagine every bit on that screen has got a little rectangle around it, that would be each one of those would be a widget, or in other languages they call them components as well. And that's made up of several widgets. And the tree, is that starts from the bottom layer all the way up, or is it top down? How does that tree work?
Yeah, it's kind of complex, but there's obviously you can. The nice thing is you can actually look at all the source code, because this is all Dart code, right? So you can literally step through every element of this. But what's going on is when you call the build methods or Flutter needs to render something, it calls the build method, and that returns the subtree of widgets for that part of the UI. And as Flutter does that build, it translates that into what's called an element tree, which is the actual tree for that Flutter sort of works on. And so each of those widgets themselves have a mapping to a corresponding element object. And some of those are what we call component elements that themselves are hosts for other elements that gradually kind of get broken down. And some of them are what we call render object elements, that are elements that participate in the layout or the painting phases. So that might be something like a raw image, which is physically an asset to be rendered on the screen. And Flutter is responsible for doing that work of translating all of those elements into gradually into the walking the tree until it gets to the lowest object of a render object, which provides Flutter all it needs then to say, okay, now I can render this tree in real time. And so if you go into the Flutter dev tools, we've built some tools that let you break down the tree and to see all of these, see the hierarchy of widgets and how they gradually are translated into elements. But it's fundamentally that render tree of the constructed lowest level primitives that are responsible for the actual painting of the tree on screen.
Yeah, the development tools are a joy to work with, and like you said, when you're using one of the GUIs, you can sort of just click one of the widget names and drill down as deep as you want. It's really nice.
Mm.
Before I move us on to some other questions, can we do a quick example of, say, you've coded up a button, you click it, and it launches the fingerprint biometric or face recognition part of your app, and you're using that type of plugin. Can you just take us down from clicking that button, what layer that's at, what it does in the engine layer, and then what happens in the embedder? Not too deep, but just to highlight the transition between the three.
Yeah, well, and you're sort of probing me to sort of the edge of my sort of architectural sort of knowledge a little bit here, but I think you're touching on a couple of points there. One is sort of how that transition sort of occurs, but then the other part is how it talks to the underlying native.
Yeah, I'm just trying to sort of translate for the listeners of how it speaks to this native part of the platform specific bit.
Yeah. So we have this sort of concept of, and there are multiple ways to do it, but we have a couple of ways to talk to the underlying platform. One is something we call platform channels, and platform channels provides a way for Flutter code or written in Dart to talk to platform specific code that might be written in something like, I don't know, Kotlin or Swift or C++. And what that platform channel model provides is essentially a pathway for those two components to talk to each other. So my custom Dart code can send essentially a binary message that is essentially a serialization of the Dart parameter that I might want to send, and that is picked up on the other side by the custom IO code from the other end of this method channel. So that custom Android code would typically have something like an event handler for when I receive this method call, then do this work in Kotlin or Java. And so that provides a relatively efficient mechanism for passing state and calls from Dart to the underlying Android or iOS or Windows code, and then returning obviously back to the Flutter side. And so typically you'd use that in a mobile way. If you look at our package ecosystem, we have, I don't know, 15,000 packages that are built for Flutter. And typically that's how they do things like, as you say, fingerprint reader or Bluetooth or camera access or any of those underlying things. We also have a second model that is designed for C APIs, which is called FFI or Foreign Function Interface. And that provides a path for Dart code to literally, from the same thread, be able to access C or C++ code by getting access to the memory store, if you like, from the Dart side to be able to interact with C code. So, for example, I can create a struct or something like that includes some state and pass a reference to that struct to the C code and vice versa. And so that's kind of like a deeper version of the same.
That's perfect. I just want to help the listeners translate that last level of how it hooks into
the
base layer. Okay, so I've got quite a few questions to dig into now that we've done that overview. How does the framework guarantee 60 frames per second? Because that's something that I've always read as the sort of a main selling point.
Yeah, in fact, the framework itself doesn't make a guarantee there. What happens is that whenever the phone or whatever device calls for a new frame to be rendered, Flutter takes that call and executes this build process that I've sort of briefly touched on.
And that's the build function of the widget, isn't it?
That's right. That's right. Yeah, and so everything comes down to a fast response to that build request, right? Assume, just to simplify things greatly, assume the 60 frames per second is a fixed frame rate. That means you have 16 milliseconds? Is that right? 16 times 60 is 1,000. 16 milliseconds for everything to occur from receiving that to having a new frame in the pipeline for the GPU to render. And so if you miss your window there, if it takes you longer than 16 milliseconds, the train's left the station, as it were. You've missed your moment, and that's what generates, sometimes people call jank, or that sort of that delay, or glitching.
Yes, a stuttery screen, isn't it? A jank.
Right. And so for Flutter to be efficient and performant, it has to do that stage fast. Now, of course, we're calling client code. If you put a thread sleep in there, you're not going to be done in 16 milliseconds. But we have a whole bunch of, like, a lot of the smarts in Flutter is around efficient tree diffing to know what needs to be re-rendered in that 16 millisecond slot. And so if we're able to guarantee that only the button that you pushed, for example, has changed, then that's the only bit of the build method we need to call. If we're able to be very specific around only repainting the elements that have changed, we can be fast. And that speed isn't necessarily 60 frames a second. It could be 120 frames a second. It just comes down to the performance of the code and the refresh rate of the phone or target device.
And that's why the general advice is to keep widgets broken down into smaller widgets with smaller build functions, so the framework can figure out not to change that bit or rebuild it.
Right, there's endless optimizations that you can make or not make. It's possible to build a bad application in Flutter just like any other framework. But we provide you with both, hopefully, good signposting and primitives to encourage you to build a performant app, and also provide you with tools to be able to see, you can actually observe your running application. You can profile it and see, when you miss the frame window, you can drill down and see, okay, I can profile it and see, well, it was this particular widget that took longer to render that pushed me over the limit. And typically what you discover is that there's opportunities to make significant differences to how your code renders. For example, if you have a key and it's possible to show, okay, this is the same as this from frame 1 to frame 2, that makes the diffing much more efficient. I now know that these two are the same thing, so I don't necessarily have to re-render everything from scratch. Or if I have a stateless widget that contains stateful widgets and it's only the state itself that it changes very irregularly, then Flutter knows, okay, that's the only bit I have to worry about. And so that's where a lot of the magic really comes down to it at an architectural level.
And that's two key important bits I've neglected to ask about is a stateless widget and a stateful widget.
Yeah, so a stateless widget is simply a widget that has no changing state. It may have things on it, like a text box that might contain some text, but if we know that text is not going to change, it's a label, we don't have to worry about every frame asking it, have you changed? And so that's what a stateless widget is. A stateful widget is essentially a widget that has some mutability in terms of the actual state itself. The mutability is stored outside of the widget because, as I said earlier, widgets themselves are immutable. But you can call Flutter with a set state method to essentially signal the framework that this widget now needs rebuilding. And that's what gives that flexibility there.
I understand. And we've touched on platform channels. That was one of my questions. And that's in the middle layer, the engine. I wanted to ask about a Dart isolate. Where does that fit in compared to a platform channel?
Yeah, so isolates are how Dart does its threading, if you like. An isolate is what all the Dart code runs in. It's essentially space on the machine with a single thread running an event loop, and many Dart apps actually just run everything in a single isolate. But you can create multiple isolates if you want to. And the thing that is sort of fairly unique about Dart is that each isolate is isolated, right? The name is the clue there. And we try and kind of create a suitable sort of firewall, if you like, between isolates. So that you kind of avoid some of the sort of the deadlocking and sort of concurrency challenges that typically come from multi-threaded programming. So in Flutter, there's a function which is called compute that lets you run expensive functions in a background isolate and return the result. So, for example, if you're doing some number crunching, or you've got an image that you're processing, you can move that work to a separate isolate.
I just wanted to highlight that sort of threading is possible in that layer.
Right.
That's excellent.
Yeah, absolutely.
Which parts of these 3 layers would you say does the most work, and which part is the hardest to get right from a Flutter developer's point of view? Not the user, as in me, but for you guys.
Oh gosh, that's an incredibly difficult question to answer, I guess. I mean, the embedder itself is fairly simple. That is its goal is to kind of get in and get out as fast as possible.
And that's the bottom layer,
it's that's that bottom level, yeah. And so that really is just setting up the run loop, as it were. The idea of the embedder is not that it's sort of integrated and doing a lot of work each cycle, right? In Windows, that might be, for example, the thing that sets up the message loop. There's this sort of classic, sort of dating back to the early 16-bit days of Windows, of a WM message loop that is passing messages. And so the embedded responsibility is to handle the WM mouse button down event, say, or something like that, and pass that on to the engine. But that's all. The engine has all the deep machinery, if you like, of Flutter, and clearly there's a lot of smarts in the engine. The framework in some ways is a little bit higher level, just by definition, right? It's leveraging the primitives of the engine itself, but it's a lot of code, right? That's where a lot of the magic comes from Flutter, in terms of the actual, like, everything that you experience of Flutter, the primitives, the principles of Flutter, they come from the framework. And so there's a lot of the interesting aspects there. And when you shift to the web, I haven't really talked about the web much and how that's engineered, but in the web it's just a little bit different, because the framework again is literally the same framework. We don't split the code base there. Your code is not the only code that's the same across multiple platforms. Our framework is itself fundamentally the same framework, but what's different is there's no C++ engine. There's no kind of ActiveX control, to use old terminology, on Flutter. The engine in the web view is simply an abstraction over the underlying browser platform, the web browser APIs. And so the web version, that's all the code that exists that is unique to the web, is exposing the web platform engine to the Flutter Dart framework.
That's a good enough explanation for me. So what do you think, or what do you know can't be done at the lowest level of Flutter? So the embedder, is there anything that you're still working on, or just isn't possible? Does that make sense?
I don't think there's anything that's not possible, in as much as Flutter really is a native experience, right? So everything that we do is using the same APIs that you would build if you're writing any other kind of native application. If I'm building a Windows application in C, I'm talking to exactly the same APIs that I'm using from Flutter, and I can use from FFI with Dart. So, we've built sort of samples that use COM, the Windows runtime, those kind of like fundamental sort of Windows API constructs from Flutter. You can build with all of those different pieces. The pieces we're still working on are exposing some of those things more natively to Dart. So, for example, you mentioned things like touch or fingerprint recognition. You can call directly any of those system services from Dart code, but it sure would be nice if there was some abstractions of those features to you as a Dart developer, so you don't have to know the underlying way that iOS or Android or Windows, for that matter, implements fingerprint readers. And so that's really, as we mature the platform and extend it, that's where the package ecosystem comes in, with those 15,000 odd packages that provide commonalized abstractions or API representations of those native.
And are those types of things done through the platform channels, or if you're doing it in Dart, does that utilize the foreign function interface, or how would that?
You can use either. Typically, if it's API in a higher level language like Kotlin or Swift, you'll use platform channels to do them. If it's C++, then FFI is a very viable technique. And so my little fun sort of evenings and weekends project outside of my job as a product manager has been writing some of that abstraction logic for Windows, given my history as a Microsoft sort of Windows kind of person. So I've taken the hundreds of APIs for some of those core aspects in Win32 and written Dart FFI primitives. And any of your listeners that are a C# developer will be familiar with things like pinvoke, and there's a website called pinvoke.net that provides a translation, if you like, from C to C#. That's essentially what my Win32 package does, is provide that same level of binding from Dart to the underlying Windows logic.
That explains why you were so excited when you did the Windows announcement about 2 weeks ago, isn't it?
Yeah, it's fun to see these different parts of my career join together at last.
Yeah, it must be a real sense of achievement. A couple of these questions we've covered. Which part of Flutter creates JavaScript for the web version? That's just the embedder, I think, now, as you've explained it.
Well, actually, it's a little more interesting than that because again, the framework, when you build a Flutter app, like when you said you did your Flutter run-d Chrome, what's happening is we're actually taking the entire Flutter framework and compiling it to JavaScript along with your Dart code for your own application. All of that gets compiled into JavaScript. And we do this thing called tree shaking, which is essentially to discard all the bits that of the framework that your app isn't using. So, if you're not using, let's say, animation in your app, then we discard all that stuff, and we only compile the bits that you actually physically have in your app, and that sort of creates this minified JavaScript source file.
Wow, that's not what I was thinking. How it worked. Excellent. So, what part of those layers, which I think we've answered already, should developers really get to know to build a production Flutter application?
Yeah, you don't need to know the engine for sure, right? I mean, that's the swan swimming on the pond. That's the legs flapping frantically underneath the water. The bit that is well worth getting to understand is the framework itself. And again, that's sort of like one of the little benefits of Flutter itself being written in Dart is that all of that code is very much exposed to you. So you never have to kind of second guess what is a button doing, what is a widget doing. You just read the source code. And indeed, we encourage you, if a widget doesn't do what you want it to do, we encourage you to just take it and copy it and fork it, rather than necessarily trying to do some awkward sort of subclassing sort of kind of model. So if you need a button that pivots in 2.5D space and does fireworks when you press the button, you can do that, and all the source is there to do that. You don't have to wonder if the button itself contains extensibility mechanisms for fireworks.
Yeah, so I've said it a few times already, but it's a really lovely experience when you're using a part of the framework and you can just click through to that layer and through to the next because it's all there, and just read some really nicely written code as well and get some ideas.
Yeah,
I think that sort of closes off for me all the different layers and how they fit to get together. But I've got a few more questions left over, and then there's a couple. I've not done this on a show before, and I did give you a heads up, but I put a request out to the Flutter community to say that I was going to have a chat with you, and if they had any questions. So I've picked a couple out of that. But just before we get onto that last bit, I saw your tweet last week, I think, about Google Pay getting rewritten or has been rewritten in Flutter.
Yes.
Can you take me through any challenges you had in relation to the architecture of Flutter or in general? But just maybe 2 to 5 minutes on it so we can...
Yeah, sure. A couple of things that are interesting about that, and of course, they're a separate team. We've
and personally, I use Google Pay app every day, so it was going to be really interesting to hear.
Oh, okay, yeah. So Pay started some of this work by pulling together a couple of different apps. They had a slightly different experience for a couple of their markets in Asia. I think India, Singapore. And there was a separately branded product originally called Tez, Tez, or Tez, I should say, that was specifically targeted at the India market. and they were working on bringing these different variants of Google Pay together. And originally, they started a small project to look at whether they could add Flutter sort of step by step, incrementally to their existing app. And they did a pilot project to see how that would play out. And it was one of those experiences where it's a bit like the experimental drug that is successful enough that you stop the trial, or you shift like sort of how the trial works. They discovered that they were actually getting so much done in Flutter that they decided, rather than do an add to app incremental migration approach, they decided, no, we're going to bite the bullet and we're actually going to rewrite the app in Flutter. And so they paused the add to app experiment and switched to a full rewrite of the project, which on the surface seems like a luxury, but really what they were trying to get was that agility of development to be able to build new features faster. And so what you're seeing right now, at least at the time of recording this in October, they are in open beta, I think, in India. I think they've shipped the new version in Singapore, and they're still rolling out to other countries. So, if you're in the UK or the US, you're probably still using the original version of the app. Although I don't know, by the time this comes out, maybe you'll have it. But it's a full rewrite. They've updated the user experience for the latest material design experiences, and as you mentioned, they wrote an article about it. They've been very, very happy with their experiences about this, and maybe we'll write a little bit more about how they built it.
Yeah, I look forward to those articles. So thanks for that. I'm going to move us on to some of the community questions in the last few minutes of the show. So one of the major things that you have to deal with every year is new versions of Android and new versions of iOS, and either preempting them or catching up with them.
Yes.
So that was one of the questions from the community, but that was probably about a month ago, and it's now the latest version of Flutter's out with iOS 14 support. Is there anything left in the iOS 14 ecosystem to support in Flutter?
There's always stuff left. I think it's true of Flutter as a whole. There's always more things that we're sort of, we've got a list of features to implement and capabilities that we want to support. But every release, I mean, as you say, there's new things that come out for Flutter and that we need to implement in Flutter, I should say, for those target platforms. We pay good attention to both sides, and now, of course, Windows and Mac and others. And usually there's a little bit of advance notice on Android. Of course, we get significant advance notice because it turns out they work for the same company.
Sometimes it doesn't make any difference, though, does it?
We work pretty closely with Android. We're tracking what's next. And on iOS, we find out at the same time that everybody else does. But Apple gives, a good few months notice of changes, typically at WWDC. And so, we have a team that's focused on adding those features. As you mentioned, in iOS 14, they added some new features like app clips, which are a bit like the Android Instant Apps support. They made some changes to the UI. And we work on that. It's a not insignificant amount of work, but we need that work anyway for our own apps like Google Pay. And so, our goal is to get that work done so that you as an end user don't have to worry about that. And one of the nice things about Flutter is because, again, we paint every pixel ourselves, we have control over the environment. You get that support sometimes going back as well. So, sometimes, Material will introduce a new component, for example. And the nice thing about Flutter is that component becomes available as we implement it for every version of Android that's out on the market, not just, the very latest version. And so that gives us, I think, a lot of resilience for the apps that are built with Flutter.
Yeah, because normally the argument for going native is that it will get a look and feel refresh instantly. But what you've explained there is that you can bring a modern look all the way back to an older Android. Is that right?
Right. Yeah, and in particular, bugs that are fixed or changes or just those differences that occur as technology moves on. You're targeting a consistent platform across each of those different devices, and so long as the device itself supports, the core engine primitives, the skier sort of primitives, etc., that gives us significant flexibility to be able to push backwards and forwards. I would just say quickly though that we do want to encourage developers to use the latest versions of Flutter itself, right? So as Flutter 1.22 came out, for example, we added support for some new system requirements in Apple apps, for example, relating to text fields. There were some changes in how they implemented that. And so by upgrading your app to Flutter 1.22, even if you don't actually make any changes to your code itself, you just recompile with Flutter 1.22, you're going to get some additional advantages and some performance improvements on the latest releases.
Yeah, that's something I do. I did an app last year and almost finished one this year, and then just rebuilding it with the latest Flutter makes tons of improvements over the previous one.
Yeah.
Okay, so summary of that is you're happy with iOS 14. There was a lot of questions about the demand or the wish for Flutter to work with Golang. Is that something you've heard about? In brackets, I've got here Go's first class targets. Is that something that you've heard in the grapevine or means nothing?
Yeah, it's funny. At my very next meeting after we're done with this is connecting with my colleagues over in the Go team. We see them as kind of quite complementary because again, as Dart is we've explicitly described it as a client optimized language. I don't think Go would be quite so explicit in calling themselves server optimized, but certainly it's a strength for them. So we see those two as being very interesting as combinations.
So something
together.
we should keep an eye on.
Maybe. Yeah, I think there's been some interesting experiments also. I've seen somebody implemented some embedders for Flutter using Go to try and, again, hit that breadth of platforms. So there's all kinds of little interesting things as part of that sort of interplay between the two technologies.
Excellent. Here's the last very specific question from a community member. Will there be a tool to move components from Angular Dart to Flutter Web?
Oh, interesting. Yeah, Angular Dart is something we use a ton internally. You mentioned ads, right? At the ad center, I forget the name of it, the ad administrative console. That's all an Angular Dart app. The Play Store is built with Angular Dart. It's a framework that we use primarily internally for those kinds of things. We make it available externally as well, although it doesn't have the same level of community support and interaction that we have for Flutter. We sort of somewhat throw it over the wall. We make it available to the community, but our aspirations for Angular Dart is not that it sort of becomes a Flutter-like sort of broad open source project. But for those apps that are Angular Darts, that integration becomes very interesting. And so, yeah, we're exploring ways to maybe be able to embed Flutter web components in Angular Darts or potentially vice versa. I don't know about a tool for automating translation from one to the other. They're very different in terms of frameworks, but I think particularly as Flutter Web starts to take off, you'll see a shift in support and componentization to make interplay between those two easier.
It's like anything in open source. If it's out there, someone, if they're interested enough, will do something over a weekend, and it'll blow everyone away.
People do crazy things. It's just, even for Flutter, I've seen examples of Flutter running on, Xboxes and Flutter running on embedded devices. I know there are companies that are using Flutter in things like fridges and microwaves as the way to show the smart displays on there. So yeah, I love that people do crazy things, and sometimes we look at those and we're like, okay, that's actually a really good idea. We should build deeper support for that in the framework itself.
I look forward to reading some more about those. Okay, Tim, I'm about to start wrapping up, although we can talk for ages on this type of stuff. So obviously Flutter is extremely important for Google and has a very exciting future. But if there was one thing a software engineer should remember from our show, what would you like that to be?
Oh, I think I would encourage people to listen to smarter people than myself. There's some great talks from folk like Ian Hickson, who I mentioned already. That talk on the mahogany staircase is a fascinating.
I'll get the link in the show note if you can drop me an email after.
Super, yeah, absolutely. Fascinating guide to again the sort of some of the underlying architectural design constraints. But most fundamentally, I think I would just come back to that original sort of comment, right? Our goal is to do something a little different to what other historical frameworks have done, whether they're sort of system frameworks or traditional cross-platform frameworks. This fundamental shift of trying to build a native, high-quality experience for multiple platforms. Shifting away from starting with your target platform to starting with the application, and trying to give you the tooling to create that native high quality experience on multiple platforms is the thing that we see as our guiding vision for Flutter. It's a big, in some ways risky bet. So far, evidence has been promising. But we continue to build on that, and being open source has it opened a whole world of interesting ideas for that, and hopefully we'll continue to develop that along those paths for many years to come.
And was there anything we missed that you'd like to mention or thought that would be mentioned?
I think you've done a great job of pulling out a lot of those interesting areas. Maybe one thing I'll just call out is the community. I think one of the things that's for us makes Flutter such a pleasure is this isn't a Google project per se, it's a Google sponsored open source project. And so some of the best aspects of Flutter have been things that are seeded from the broader open source community. The null safety work that's going on has been largely driven in terms of the migration itself by a non-Google contributor. And there are many other examples of that, from big companies like Alibaba to tiny, single individuals with a great idea that they've implemented. And that makes Flutter bigger than anything that Google can bring. The majority of contributors to the latest release of Flutter came from outside of Google. And I hope that continues for a long while to come.
I did like that when you do, I think you've been doing it for a while, where you do the release announcement and then it lists the sort of top 10 contributors.
Yeah.
And it's always really impressive to see that they're not Google people.
Yeah.
Just one question before we go. How big is the team within Google for Flutter and Dart? Is that something you're allowed to share, or?
Yeah, I guess we have about 100 people across Flutter and Dart, spread across engineering, product management, marketing, developer relations, spread across Flutter as a framework, Dart as a language and a runtime, probably about 100 people.
Oh, that's really cool. Where can people find out more? Obviously, they can follow you on Twitter, but if someone wanted to get in touch, what would you recommend?
Yeah, a couple of places. Of course, again, being open source, all of our source code is on GitHub, our roadmaps, our issue logs, all of those things are there. And that's where the team spends most of our time. It's what drives everything we do. We don't keep a separate backlog that isn't the published GitHub backlog. Everything that we do there is visible. Also, we chat. You can find us on Discord, where we have our various different engineering chat rooms. And that's sort of the place if you're physically contributing towards Flutter, or you have a question about a feature you're trying to add to Flutter. That's a great place to go.
Okay, Tim, thank you for coming on the show. It's been a real pleasure. This is Gavin Henry for Software Engineering Radio, and thank you for listening.
InterSystems Iris is the fastest way to build applications. So take advantage of that extra time on your hands and use it to learn a new data platform. Deliver complex mission-critical applications on the fastest route possible, with data from any source, embedded analytics, and interactive user interfaces. With InterSystems Iris, you can connect your systems, use any data model, and apply machine learning. Now's the time to level up your database platform and try out InterSystems Iris, so you can collaborate, build, and deploy faster than ever before. Don't wait any longer. Level up your skills with InterSystems Iris. Ready, set, code. Visit intersystems.com/tryiris to learn more. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.